Okay, here we are, quarter four, week 3, day 1. We are going to solve a subtraction problem and a addition problem, both with decimals. So we're gonna have to line up the decimals. So let's do the subtraction problem first. We have 3,390.02. And now let's line up the decimals. So we have 67.008. All right, so we're going to have to put a 0 right up there. Let's subtract. Can we take 8 away from 0? Nope. So we're going to have to borrow from this 2 and make it a 1 and make that 10. 10 minus 8 is 2. 1 minus 0 is 1. 0 minus 0 is 0. Put the decimal point down there. Can we take 7 away from 0? Nope. We're going to have to borrow from the 9, make that an 8. So we have 10 minus 7 is 3. 8 minus 6 is 2. 3 minus nothing is 3. 3 minus nothing is 3. There we go. Then we just come over 3 places, put our comma. So we have 3,323.012. That's the answer to the subtraction problem. Okay, so let's do the addition problem. Again, we have to line up the decimals. 394.029. All right, then we have the 5.0 or 5.38. 5.38. Okay, we're going to be adding. All right, we could put a 0 here if we want to. All right, so we're going to put a 0 underneath the 9. So 9 plus 0 is 9. 8 plus 2 is 10. Put the 0, carry the 1. 3 plus 1 is 4. 5 plus 4 is 9. 9 plus nothing is 9. 3 plus nothing is 3. Bring down the decimal. So we have 399.409. Okay, that's the answer to those two problems, the subtraction and the addition problem. All right, now we need to fill in the blank, and we are comparing kilometers to meters. Right here, I show that the ratio of kilometers to meters is there are 1,000 meters for every 1 kilometer. So if we want to get to how many meters are in 8 kilometers, we'll just put the 8 right here. 1 times what number? Because we have to scale it up to that. What times what number? 1 times what number will give you 8? Obviously, that's times 8. So you're going to do 1,000 times 8. Well, that's pretty obviously 8,000 meters. So that would be our answer here. So 1 kilometer is 1,000 meters, so 8 kilometers would be 8,000 meters. All right, so what is the value of 7x minus 2x plus 3 when x equals 5? So basically, we're going to put 5 in wherever there's an x. So let's just rewrite it with the 5 in there. So we have 7 times 5 in place of the x, minus 2 times 5 in place of the x again, plus 3. All right, so we have to do, if we're doing PEMDAS, we have to do the parentheses first. Well, everything that I put in parentheses is just one number, so the parentheses are done. Then we have exponents. Well, we don't have any exponents. Now we have to do either multiplication or division. So there is multiplication here. Right there is multiplication. Right there is multiplication. So let's do those. 7 times 5 is 35. So this becomes 35. Minus 2 times 5 is 10. Plus 3. So now we're just left with addition and subtraction. And according to order of operations, usually it's you hear the M, multiplication, before the division. But when all you have, addition before the subtraction. But when you only have addition and subtraction left, you just go left to right, just like you're reading. So instead of doing addition first in this situation, we're going to do the 35 minus 10, which is obviously 25 plus 3. And then to get our final answer, we're going to do 25 plus 3, which is 28. All right, so our answer for this one, once we put in 5 for all of the x's, okay, is 28. All right, now we need to find the volume. Volume equals length times width times height, right? So So volume is the three-dimensional small cubes inside of a larger cube. So how many basically cubed centimeters would fit inside of this box that we have here? Okay, so we have to do length times width times height. So it doesn't really matter what order we put them in because it's multiplication. So I'll go ahead and just write it out. 10 1/8 times 3 times 8 1/3. Okay, we have to change these mixed numbers into improper fractions. 10 times 8 is 80, plus 1 is 81. So it's going to be 81 over 8. 3 just becomes 3 over 1. And 8 1/3, 8 times 3 is 24, plus 1 more is 25. So we put 25 over 3. Let's see if we can do any cross-reducing. To save us some time later, I see that we can cross-reduce the 3 and the 3. This will become a 1, so we don't have to simplify that. That'll become a 1. Is there anything else we can do? I don't think really. So let's go ahead and solve this. We have 81 times 1, which is still 81, times 25, and that equals 2,000. Okay, that equals 2,025. Okay, and then down below in the denominator, it's just 8 times 1 times 8, or 8 times 1 times 1, which is just 8. All right, so let's see, how many times does 8 go into 2,025? So we'll do 2,025 divided by 8, and it's going to go into it 253 times. Okay, but if we do 253 times 8, that's 2,024. So we've used up 2,024 of the 2,025. So how much is left over? Well, there's just 1 left over in the numerator out of 8. Okay, so there's our answer, 253 1/8, and it's going to be in what? Centimeters, it's volume, so cubed. Okay, so 253 1/8 centimeter cubed. All right, next we're going to do something with mean, median, mode, and range. Remember, mean is the average. So you add up all the numbers and divide by however many numbers are in the data set. Okay, then the median is the number in the middle of the data set. So you just line them up, remember, from least to greatest, okay, and find the number in the middle. The mode is the one that happens most often. So in the data set, if there's multiple 2s, there's more 2s than any other number, then the mode is 2. If there's more 5s than any other number in the data set, then the mode is 5. And then the range is the distance from the highest to the lowest number. So you find the highest number in the data set and subtract it from the lowest number in the data set, and that is your range. Draw a line plot to correctly display the data. All right, so let's look at the data. How many 2s are there? There are 2 2s, so I'm going to put 2 X's above the 2s. Is there any 3s? There's 1, 2 3s, so we're going to put 2 X's there. Are there any 4s? There's 3 4s here. There's no others, so 1, 2, 3 X's above the 4s. Let's see, is there any 5s, 6s, 7s, 8s? There's a 9 right here. So we skip up to the 9 and put an X there. And then there's, the next ones are we just have 2 20s left. So then way up here, we have 2 20s. All right, we have created the line plot. Now we need to find the mean, median, mode, and range. So I like to start off with finding the median because it's the number in the middle, and it's the easiest one to find. So if we start kind of eliminating the numbers on each side until we find out what number is in the middle, Looks like we have a shared middle of a 4 and a 4. Okay, so of course, if you take 4 plus 4 and divide it by 2, because we're going to need to find the average of them, we end up with 4. So we're done finding the median. That was easy. And by the way, I did put the numbers from least to greatest, and I just used the line plot because I knew I put 2 2s first and then 2 3s. So I used this information down here to make it really easy to write them in order. All right, the mode is the one that happens most often. Well, that's really easy to find now because of our line plot right here. We have more x's above the 4 than any other x's. So the mode is also 4. Okay, and there's not a shared mode because there's not another one that has also 3 x's. Then we have the range. Well, the range is the largest number that we have in the data set, which is 20, minus the lowest number that we have in the data set, which is 2. 20 minus 2 is 18. That's our range. And then we have to find the mean, which means we have to add all these up and then divide by however many numbers are in the data set. We're going to put 20 plus 9 plus 4 plus 4 plus 4 plus 3 plus 3 plus 2 plus 2, and that equals 71. Okay, so 71 is our total. Then we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that shouldn't be too hard because we know if we divide by 10, we just move the decimal over 1. So the mean is going to be 7.1. All right, and then which one's the best measure of center? Well, because the data is so skewed, we have some way down here. We have one little thing by itself here, and then a couple way out in the middle of nowhere. That's going to mess up the mean. Okay, so we're not going to use the mean as the best measure of center. In this case, we would use the median, the number that was in the middle. So 4 is much more representative of the larger clump of data than basically a 7.1, which would be out here kind of in the middle of nowhere, right? So the median is the best measure of center. Draw a box and whisker plot to represent the data. Okay, so we already have the indicators here. The 14 right up here is the middle. That is the median. Okay, the 22 is the middle of the upper half of numbers here. The 9 is the middle of the lower half of numbers. Then, of course, the 7 is the lowest number, and the 24 is the highest number. So to make the box and whisker plot, okay, we use the 14 that's in the middle, and then we use the middle of the upper half of numbers and the middle of the lower half of numbers and plot those, and then the highest and lowest number. So that's our box and whisker plot. We found the median of the whole data, the median in the upper half, the median of the lower half, and then the highest and lowest number. That's all you have to do to make a box and whisker plot. Graph the integer -2 and its opposite. Okay, well, let's just graph -2. Put a dot right there. Well, the same distance on the other side of 0 is going to be its opposite. So we're going to put a dot there. That's all you have to do. -2 and +2. So -2, the opposite of that is +2. Graph the ordered pair 0, -4, and its reflection over the y-axis. All right, over 0. So we're just not going to go left or right at all. We go down 4. 1, 2, 3, 4. That would be right there. And then the reflected over the y-axis, well, that's this axis. So it doesn't reflect. It just basically flips. If it was a coin, you would just flip it over and it would look like it's on the same spot. So that's it. We are finished with that graph, with both the graph and the reflection. Place the following numbers on the number line. So I have them color coded. You can kind of see right here. This is the orange one, this is the blue, this is the light blue, and this is the kind of reddish pink. So there's where you would plot it. The 2.75 would kind of be close to the 3, and there you go. So that's how you would plot each one of those decimal numbers.